Good day, everyone. So, today I'm going to discuss the Packet Tracer Investigate STP Loop Prevention. Objectives. In this lab, you will observe spanning tree port states and watch the spanning tree convergence process. Describe the operation of the spanning tree protocol and then explain how spanning tree protocol prevents switching loops while allowing redundancy in switch networks. We have here our background or scenario. In this activity, you will use Packet Tracer to observe the operation of spanning tree protocol in a simple switch network that has redundant paths. Part 1. Observe a converged spanning tree instance. Step 1. Verify connectivity. Ping from PC1 to PC2 to verify connectivity between the hosts. Your ping should be successful. So, go to PC1 and then click the command prompt, then type ping and then type the IP address of the PC2, which is the 192.168.1.101. Then click enter. So as you can see, it is successful and it is connected to each other. The next, step 2, view spanning tree status in each switch. Use the show spanning tree VLAN1 command to gather information about the spanning tree status of each switch. Complete the table. For the purposes of the activity, only consider information about the gigabit trunk ports. The fast Ethernet ports are access ports that have end devices connected and are not part of the inter-switch trunk-based spanning tree. So we have here our table, which is the switch, port, status, which is forwarding and block, and then the root bridge. So go to S1 and then click CLI and then enter. Type enable, then show spanning tree VLAN 1, then click enter. So as you can see, our GI0/1 and GI0/2 is on forwarding states. So here, this one. And then the root bridge, the root ID address is not the same to the bridge ID address. So it is a no. So it is a no. Our bridge ID is no. Then go to S2. Then enter. Type enable. Then type show spanning tree VLAN 1. Then click enter. So as you can see, our GI0/1 and GI0/2 is on forwarding states. But our root ID address is the same on our bridge ID address. And it is said here that this bridge is the root, this one. So our root bridge is a yes, since it is a root. Okay, it is a root bridge. Okay, this one. Then go last to S3, then type enable and then show spanning tree VLAN 1, then click enter. So we have here our GI0/1, which is on forwarding states, this one, but our GI0/2 is on blocking state. And then our root ID address is not the same on our bridge ID address, as you can see. So our root bridge is no. Okay. And then next is, what do you think this link light means? This one. So it indicates that the port is not forwarding frames because it is in spanning tree state. In this case, it is the blocking state. Okay. Next is, what path will frames take from PC1 to PC2? So from PC1, it will go to S1, then S2, and then last to PC2. Okay? Then, why do the frames not travel through S3? So, their main reason is the spanning tree has placed port G0/2 on S3 in blocking mode. So, no frames are sent or received on that port here. Okay? Then part 2, observe spanning tree convergence. Step 1, remove the connection between S1 and S2. Open a CLI window on switch S3 and issue the command show spanning tree VLAN 1. Then leave the CLI window open. The next is, select the delete tool from the menu bar and click the cable that connects S1 and S2. So go to S3, then type show spanning tree VLAN 1. Okay, sorry. Then leave it open. Then go to the delete button, this one, and then click the connection of S1 to S2. So this one. Okay. So as we can see, there is no connection to S1 to S2. Okay. And then next is step 2, observe spanning tree convergence. Quickly return to the CLI prompt and switch S3 and issue the show spanning tree VLAN 1 command. Use the up arrow key to recall the show spanning tree VLAN 1 command and issue it repeatedly until the orange link light on the cable turns green. Then observe the status of port G0/2. So up arrow key, enter. The next, what do you see happen to the status of G0/2 post port during this process? You have observed the transition in port status that occurs as a spanning tree port moves from blocking to forwarding states. Okay? Then, first it was block. Okay. First it was block, then LSN or listening, then LRN or learning, and finally found FWD for forwarding. So next is verify connectivity by pinging PC1 to PC2. Your ping should be successful. So, and then lastly is, are any port showing an orange link light that indicates that the port is in a spanning tree state other than forwarding? Why or why not? So, go to PC1, then click command prompt, then ping 192.168.1.101, which is, this one is the IP address of PC2. Then click enter. So, as you can see, it is successfully connected to from PC1 to S1 to S3, S2 to PC2. So, it is successfully connected to each other. And then, are any ports showing an orange link light that indicates that the port is in spanning tree state other than forwarding? Why or why not? So as you can see, there is no orange link light of course. Yeah. So all, so there is no longer redundant paths in the network. Okay. That's all. Thank you for listening and have a good day.